So we now move on to the talk of Thomas Hermans, who will tell us about the JEDI Grand Challenge.
Okay, good afternoon, everyone. I hope you can hear me properly. So I'm Thomas Hermans. I'm a professor in chemistry at the University of Strasbourg. Since the last couple of weeks, I'm the program manager for JEDI on a grand challenge to find a new therapeutic for the COVID virus. And please visit this website. So we're launching a global challenge where basically all teams can participate. And we want to tackle, we want to reach a number of moonshots. So moonshots are very challenging targets that we are trying to reach. So we're trying to, I will show you the details, but we're trying to model a number of components at a huge scale. And we try to get a very high hit rate. So we try to get a very high accuracy in the compounds that are predicted by cross-correlating the results of all the teams that are submitting to our competition. And we have experimental validation in place. So these compounds will be synthesized, they will be tested, and we will get hopefully high viral reduction. And also we have a track on finding new drug cocktails. So how does it work? So in stage 1, which is opening very soon, we encourage teams to screen over 1 billion compounds using 3 independent methods. And for that, we are also providing help and infrastructure. So on the first side, we are helping to identify the best protein targets. So for this, we are working with a number of partners. So we have the Corona Structural Task Force by Andrea Thorn, who's taking the X-ray diffraction structures and refining them to get the highest resolution 3D models. And people at Folding at Home, which is a crowdsourced initiative in the US, are doing energy minimizations on these structures. And also the simulation data and these targets will be all combined by MOLSI, which we will provide the details on our website. On the side of the chemical compound libraries, we're trying to get the biggest possible library. So there's, of course, the well-known Zinc-15 library, which has like 1.4 billion compounds. But we have also partnered with Merck, and they are opening up their own libraries, which we have already cross-checked against Zinc. And we have identified 1 million new compounds that have not been in there. There's also CAS, which is division of the American Chemical Society, who has put 50,000 antiviral compounds available. And there's, of course, the Sweet Lead library, which has about 7,000 compounds that have been known to be used in humans. So these two together, the targets, the compound libraries, and we're also helping on the computational part. So we have agreements with PRACE, which is the European supercomputer cluster, with GenC, the French one, and we also have private partners that are putting CPU and GPU hours available for the teams that are participating. So after stage 1, we will have a number of lists of all the teams that will cross-correlate to get what we call the ultimate list. So the ultimate list will then, together with Merck, we will screen which compounds can reasonably be made. They will be turned into a physical library of 500 to 1,000 molecules, which we will run affinity assays against recombinant protein targets using our other partners that are in the challenge. And this will give us real binding affinities experimentally determined. And based on that, we will rank the teams, the simulation teams, and award 250,000 euros to the top ranked team. Then in stage 2, we take these molecules with the known binding affinities, and we encourage teams to screen them using live virus assays on cells, and to do that in whatever way they want. But basically, we want to find a compound which has a more than a 2 log reduction of the live virus yields. And on top of that, we want to have at least 100 of these top-ranked compounds from all these ultimate lists to get the data from those compounds. Again, in this stage 2, there's a prize of 250,000 euros. So in the last stage, this is so the first 2 stages are basically a top-down approach where we go from billion compounds, we select 1,000, we screen them, and then we go up. But of course, if we want to have a treatment that is immediately available, repurposing is the way to do it. And of course, many initiatives are already working on this. So the novelty we're trying to bring here is that we are hoping to find compounds that have synergy with each other. And this has been recently developed for HIV. So we hope this approach will also be used for COVID, because it allows us to skip basically the step of one drug, one target. That is the most commonly used. So again, we leave it free to teams to determine how they will do that exactly. Teams have to screen at least 1,000 different FDA-approved compounds, and they can do the screening in whatever way they want. But in the end, we are looking for a cocktail which has this more than 2-log reduction of the virus, plus a validation in an animal model. And the top-ranked team here will be awarded up to 1 million euros. So that is our challenge. We are, the official launch is very soon. We were up to now in a pre-launch stage where we were collecting feedback from the scientific community, which we did get. So we're now refining all the metrics. So what you see now is what will go live in a couple of days. So please sign up your teams on our website. There will be also a communication platform to communicate between the teams. And we hope you will all participate. Thank you.